Hello everyone. It's finally warmed up a little bit here today, and that's why I'm out in the shop. It's been so cold lately, and it's warm enough today. I said I'm gonna go out in the shop for just a little bit. I picked up a Syncor TF-151, and what this is a transistor and FET tester. And yeah, I got those little Chinese testers to check that stuff with, but this thing here, from what I can remember, I used to have one just like it when I worked in the electronic shop back years ago, and it's really good for checking gain and stuff on transistors. And I got a piece of equipment that I'm going to be working on here in the near future where we'll need to test the gain of some transistors, and I'd rather use this piece of equipment. However, this thing doesn't work, so we're going to in a future video tear this thing down and restore it and get it back working just like it did when the day it was purchased new. Shouldn't be too hard. It's a fairly simple circuit, so yeah, it should be pretty easy to get this thing up and going. But we'll restore it, get it cleaned up, and get this thing working. So what I got here is some random digital multimeters, and this Klein, I use it quite a bit here in the shop. Y'all have seen this in a lot of videos. It's just been a very good, dependable voltmeter. And then I've got the Fluke 27 FM that I use quite a bit. But what happens is I'll constantly grab one of these meters and carry it out in the garage or out in the yard to work on something with automotive or tractor or whatever. And sure enough, I'll knock the thing off and scar the display up. This one's got two heavy scratches in it here. This is the one I use the most of the time, and you can see how it's gotten dirty from greasy hands and stuff, but it's got a big old scratch across the display. You might be able to see it there. And even this here, it's got a bad scratch across the front of it. Now this one, I very seldom use it out in the garage, because this is an old meter. It's an old Tesmen. These push button style meter works good. It's not that accurate, but I'll take it out there from time to time, but not that much. So normally what I've been doing is going down like Harbor Freight. I pick up one of those little cheap multimeters they got and try to keep it out of the shop. Well, I probably bought a dozen of those things, and I don't have one that works today. Every one of them has quit or got slammed with a car door or a hood shut on it, or or something. Cheap meter, don't worry about it. You break them, you throw them away. So not too long ago, an Amazon seller contacted me, and it's from Tesmen. And they sent me this Tesmen, that's the TM-510 smart digital multimeter. And it's auto ranging, non-contact volt, has a flashlight, data hold, LCD backlight, and 4,000 count. And not only did they send me one, they sent me two of them. And the thing is, I'm going to give these away. And not only did they send two for me to give away, they also gave me a code to use. So if you guys wanted to go out and get one, you could get one 10% off. Now when a company does that, I have respect for them. Whenever they offer, like I said, instead of sending one, they sent two. they've given me a code, which I'll link in the description box below, that you can use to purchase one. Now this meter is only like 12 bucks, and you know, it's what I would call a disposable meter. Something goes wrong with it, you just throw away, go get you another one. I wouldn't even attempt to go inside and use it, or you know, to repair it. And I would not use this on any high voltage like you on the bench. I think this would be a good, you know, a pretty decent garage type multimeter, or something to throw in your glove box of your car if you need to test something. But hey, yeah, 2 of them. So we'll end up giving these away. We'll probably give them away to just United States only, because as cheap as they are, you know, it's not worth shipping costs over, you know, international. But we'll take one out and just have a look at it. There's a user manual, if you can read that, but the front half of it is in English. And you see they send it in a little carrying case. You know, that's just perfect to throw in your glove box of your car. Okay, so we got our probes, and you know, this is plastic PVC wire. It's pretty flexible, but you know, it's not nothing that will handle any high voltage, and I wasn't expecting that in this meter. And you can see it has a green case on it. The little meter itself is gray hard plastic, but it's got this soft rubber green bumper on it. And looks like they come either green, red, or blue. So I done put batteries in one of them. I haven't done the other one yet. And so you can see it's completely auto ranging. Does AC, DC, ohms, and continuity. There's a backlight. I guess you hold it. Yeah, you hold it for the little flashlight, which is, you know, pretty nice, because I've seen some of them. In fact, the last one that I had that was sent to me, you would hit the backlight, and when you hit the button again, the flashlight came on, and you had to cycle through it to turn them off and on. But this one just hit it one time, turns it on, turns it off. The MCV, switch it here, and let's see if, oh yeah, that does work on this one. The last one I used did not work that good. I can't remember what brand that was. So here's my mag light and arm. And you know, the electrical wires run through these metal braces. I'll show you how sensitive this is. That's pretty sensitive. That's nice for finding if you get ready to place a receptacle. It's nice to make sure you got the right breaker turned off. That's pretty impressive how well that one works. And back to auto. But you know, the main thing, does it work as a multimeter? Let's turn the backlight on. I got my tester here. We'll look at DC volts, and 5.0 right spot on, no problems. Now I'm going to switch just to AC, and I'm just low the AC. I do not think auto range is going to kick in on it. The last few multimeters I've checked like that did not pick up the AC current, and this one does. 4.98 AC. That's impressive. And the last couple ones I've checked would not. Okay, how about resistance? Let's look at 100 ohm. .98 ohms. 1K. That's 1K spot on. 10K. And there's 10K spot on. And you know something I am noticing about this one, it's picking up what it senses quickly. The last one I had that I was checking, it would sit there and you had to wait about 3 to 4 seconds for it to detect. That's very annoying. And there's 100K, and that is spot on. Let's check it on a little bit higher voltage. It's 124 volts AC, no problems at all. Now it does say on this right in front of me a max 600 volt. Saying 600 volt cat 2, but I wouldn't always I wouldn't want to use it on 600 volts. I'm gonna be honest with you, especially if it's got some good amperage to it. You know, when I look at something like this, I just don't see the protection circuitry built in these little things that you would have in a more expensive multimeter, and that's why I say this would make a good grab and test something, you know, like a wall receptacle or a light, or out in the car or something. And another thing, I don't think the backlight is on a timer. It looks like the backlight stays on until you cut it off. Now that's, you know, will eat batteries up, but hey, if you're out there working in the dark and trying to test a few things, that's pretty nice. So let's tear into this thing. Case is pretty easy to get off of. This is when we'll get into the pros and cons of little items like this. And one of the first things that I don't really like about it is the screw that holds the battery door on. I mean, 2 cents to make a screw that would be retained in the battery door. Because if you're out again in the dark or outside and your batteries go dead and you got to take the case off, chances are you'll lose that little screw. I mean, you know, if the company made this, do away with the flashlight and put the money in a screw that won't fall out of the battery door. That's the way I look at things, you know. Again, I'm not expecting to see a whole lot inside of this meter. Most of this stuff is one chip on the board. There's no nothing but press button switches on it. Okay, you can see the battery just has tabs that stick out and press against two springs here. You can see that's the flashlight LED. Nothing special about the connectors here. They're just formed metal loops that's pressed into these bosses. And you can see there's our main processor chip. We've got a few transistors, some other components, another transistor there, a couple down here, input protection, and that's about it. And you know, that's exactly what I was looking to see in this thing. You know, for 12 bucks, that's not a whole lot. You can build into something. Another thing I'm impressed with, they got 6 screws holding the circuit board in. And you can see there's looks like no components on the front. This is our sensor for the no contact. It's just part of the circuit board. A little LCD display with a zebra strip on it. And you can see our touch pads for our buttons here. And that's it, guys. Looking at this, we can see our common trace goes up here and goes directly to the chip. The input trace goes through all these components here. They do have some separation between the common and the input. There's no isolation in the board or nothing, but you know, what do you expect for a little meter like this? So we're looking here under the digital microscope, and you know, it's laid out nice, and the soldering job, like it was all reflowed, and looks real good. So that's, you know, that's about it. Well, there you go, guys. I put it back together. Will it still work? Oh yeah, no problems at all. So, you know, I would prefer this over the Harbor Freight meters. That's definitely no questions about that. I think the Harbor Freight meters, what, $6 or something? I don't know, it may even be more now, the way things is skyrocketed now. But this meter's about 12 bucks. You can go on Amazon to I think it's running it for another month or so. I'll have the information. I have the information listed in the description box below, and along with the code to get the 10% off. You're probably looking at about $9 or so. But yeah, it's. I would definitely buy these before I go back to Harbor Freight and buy one of those. You know, just Looks like a pretty decent little, what I call, disposable multimeter. And there you go, guys. Tesmen TM-510 smart digital multimeter. If y'all want these, just leave a comment down below. Like I say, we'll give both of these away, so it'll be a double drawing. And just tell me that you want the meter or not. And again, guys, you know, this is not for everyday work, high voltage stuff. Stay away from it with these. You know, like I say, automotive, simple things like, you know, checking receptacle, something like that. What I like about it is the no contact voltage sensor. It seems to work real good on this meter. It's good for just going up to a circuit and see if it's working or not. Good for tracing down problems, you know, you might would have with receptacles or lights that's not working. Again, I'll leave the information down in the description box, the link and the code to get 10% off, and I'll leave the information on how long that's going to run down in the description box. So what I want to do is just take our little Tesmen meter and just do a little bit of troubleshooting on this Tesmen TM-510 transistor tester. Now I've got a brand new old stock ECG 198 transistor, and I don't have any test leads made up for this yet. That's something I need to do. I need to order a pack of little mini grabbers, so I can make some test leads. I got several pieces of equipment I need some good little mini grabbers for, and in this one I need a black, yellow, and a red, so you can keep and a blue for the FET to connect to the gate. But I got the transistor hooked up. Make sure my clips ain't shorting out. And we'll turn this on, and actually in this position we should see some deflection on the meter, and there's nothing. I've even tried it with an FET and there's nothing, no deflection whatsoever on either side, standard transistor or FET. So that's a good indication of what may be going on inside of this thing. I'm thinking that the voltage rail is missing. But yeah, there's nothing. Doesn't do anything. So we'll turn this back off. I want to hook all these leads. Got the mains unplugged. And let's see, 2 screws on the bottom. I see 4 screws on the back that's holding this in, but they may also be holding the chassis inside. We'll go ahead and take these out. And you're seeing this as I'm seeing it for the first time. Yeah, there's definitely something else holding it in there. Let's try these 2 middle screws. Like I say, my plans is to do a full restore on this piece of equipment, because I would love to have it back functioning as it was when it was new. I had one of these at the electronic shop I worked at for 25 years, and I just like using this old, yeah, it's coming out now. But I like using this old style equipment like this. Looks pretty clean inside. Let me get this case off. Okay, so all you see on top of the chassis is the meter itself, and there's two potentiometers coming out. And on the bottom, there's two different transformers. I see 3 electrolytics, 4 electrolytics. Some resistors and diodes. So it really can't be a whole lot unless something in the wafer switch has gone bad. But let's look at the schematic. Okay, so we'll have a peek at the schematic here. And you can see this is our mains input, and it goes to those 2 transformers I was just showing you. But if we go here, we see the on-off switch. And up here, the first thing that catches my eye is they have a 2-watt resistor. It's a 5.6K. This is a little hard to read since it's a scan, but I was able to pull it up on the computer and look at it. And this basically feeds voltage to the beta cal control, and that's not working. And what I like about the way Syncor did a lot of their products is that they put a troubleshooting guide in here. And it says right here, the very first symptom, leakage in GM is okay, but no beta cal. R2 is open. Check with ohm meter and replace if necessary. And then there's meter pegs not there. GM 0, no effect, it's not there. Beta okay, and we know it ain't there. Beta leakage okay, no, because beta's not working. GM reading high or low, no, we ain't getting nothing. No leakage reading, beta okay, no. Meter vibrates, so the meter's not doing nothing. So that's your first giveaway right there. No beta cal, R2 open. And R2 is that 5.6K resistor. That's right here. And I'm looking through the parts list. It's strange that R2 is not in the parts list. They left that out of the parts list for some reason. Okay. Well, let's just take a shot in the dark and see if their troubleshooting guide is any good. Okay, I've looked inside and I think I've located R2. If you see right here, there's a white ceramic looking resistor. Let me zoom in on that for you. There we go, right there. And there's 2 things I see on it. Most of the ceramic coating is broken off of it. And if you look right here at the chassis, you see that spot on the chassis right here? Looks like something's leaked out of this thing and corroded the chassis. So that's supposed to be 5.6K. So let me get a multimeter on it and check it and see. When I have the meter turned on, let me see if I can get it here and get something. Yeah, I can go to the back of the switch and to this end of that resistor. See it right there. $148 ohms. That's definitely out. Just to make sure there's nothing else in that circuit, I'm going to desolder one end of that resistor. Yeah, that was easy enough. Now we'll go back and check it again. Well, according to this, that resistor is completely open. Let me go back to the switch where it's connected to. Yeah, that's reading straight across as a short because of the line cord. Well, it looks like this 5.6K resistor is toast. I'm going to go ahead and desolder the other end and see if I can find a 5.6K resistor and solder in, see what happens. Okay, I got this resistor out, and you can see just how bad it looks. All the ceramic coating is burnt off of it. And we'll check it again. And you can see the meter is not even able to read anything off of it. I'll grab the old standby. I don't know if you can see that, but we're getting OL, so that resistor is bad. So this is the case where our troubleshooting chart was pretty accurate, and that meter even told us that when we checked it. Okay, I know it's hard to see, but down in there I soldered a 5 watt resistor across the circuit, and let's see what this thing does now. Alright, same transistor as before. Plug the mains back in. We'll turn it on. I'll go ahead and turn this down to start with. I saw the meter jump. We'll put this on low power ×1. Yep, there we go. We'll set that to beta cal. Press the gain. It's about a 49. We'll go to high. Recalibrate. That part's very touchy, needs cleaning. Gain looks about 850 on it. We go down to the leakage test. We got just does move the needle up a little bit, so the leakage looks good. So that's all was keeping this meter from working, was this resistor. So keep your eyes in the future coming for a restoration video on this. Alright guys, that's it for now, and we'll see you in the next video.